Okay, we're now ready to start programming this part on the ProtoTRAK SLX control. Again, let's remove the top portion and focus only, for now, on our finished profile. So we'll select Program. Again, we don't need to give it a name unless we're going to save it. If we're going to save it, we could give it a name at that time. So let's just press Go to begin. As I said, the removal of stock and the semi-finish and the finish cuts are all done using cycle. Select cycle, it says, okay, where do you want to begin in X and Z? That would be the start point of the finished profile, which is, in this case, X0, Z0. And it's asking us for a depth of pass for a rougher. Let's take 50 thousandths per roughing pass. Do we want to approach along the x-axis or the z-axis? Typically for OD work like this, you're going to be running along the z-axis. So press Z and press set. Now it's asking us for our roughing speed. We can express that as either RPM or surface speed. And we'll enter in here 500. As you can see here, I've entered 500. Now, if you push your incremental set button, you'll get 500 RPM. If you push the absolute set button, you'll get this value in surface speed. So I'm going to push the absolute. That's the way I like the program. And the same thing applies for feed. Let's enter in 10 thousandths. And if you push ink set, it'd be 10 thousandths inches per minute, which wouldn't work, by the way. But if you push abset, you'll get 10 thousandths per revolution. It is possible to mix surface speed and feed per rev. I'm sorry, to mix RPM and feed per rev and vice versa. Like for drilling, you could specify 500 RPM and 2 thousandths per rev. That's your choice. The tool number here is for your roughing tool. And you'll see finish cut has come up here. And the question mark has popped up. When the question mark pops up, that means that the help key has functionality that differs from the math helps. Anytime you see this blue key pop up, the question mark, press your help key. And it's asking us here, I've just pressed it, it says, would you like to add a separate Z finish cut? Well, I've got a 90-degree wall here, here, and here. So if I'm leaving 20,000 stock on here, I may not want to leave 20,000 stock on these 90-degree walls, or I'll pull a wide chip and get a bad finish. So I'm going to add a separate Z finish cut. So the first cut here for your finish cut is for the X, or diametrical. Everything on this lathe is diametrical. The Z finish cut you can have separate from the X, and I'm going to put in here 4 thousandths. I'm going to run this probably at 650 surface speed to finish and about 5 thousandths per revolution. I'm not going to use a separate tool to finish. I'm going to use tool 1 for roughing, and I'm going to use tool number 2 for the finishing tool. Now what we're going to do is describe the geometry itself using cycle turn or cycle arc, or any combination of the two, to define the finished profile. I'm going to assume that we're running 3 1/8 stock and that this here is already to size. So we're going to program out to this point, which is our finish point is going to be at a 3-inch it's going to be at a 3 1/4 inch diameter and -4 inches along Z. So to begin cycle, we start at the start point of our finished geometric shape, which we did. We told that it was 0, 0. So going from here out to here, this is 1.5 inches diameter. That's a turn move. So we're going to turn out to X of 1.5. Z is staying at 0. And at the end of this, we have a chamfer of 140 thousandths. And you see here I've entered 140. And if I push the absolute set button, I'll get a chamfer. were I to enter 140 and push the incremental set button, I'd get 140 radius. I need the chamfer. I push the offset, and it says that I put a chamfer at the end of that. Now we're going to turn from here, this 1.5" diameter, back to 1.5" deep along Z. So turn. I'm going to just push ink set for the X end because the X begin and the X end are the same. I'm staying at that 1.5" diameter. And the Z end is at -150. Oh, I'm sorry, minus 1.5. At the end of that, there's also a chamfer of 70 thousandths. I'll put it in there and tell it to give me the chamfer of 70 thousandths. And if I press my look key now, I can see that I've got that going. I certainly don't have a chamfer here yet because there's nothing for it to connect to. Pressing look will take you back to the program. Now we're going to turn out to this 2" diameter. So we'll say turn to X of 2. Z is not moving, it's a straight line. And at the end of that, we have a chamfer. Oh, I'm sorry. At the end of that line, we have a radius here. Let me just show you on the top. At the top of this, we have a radius of 50 thousandths. So we'll say 0.05. And we're going to push the ink set button to get a radius. And you can see it says Conrad now, 50 thousandths at the end of that. You can press your look. Not a bad idea to press look now and again, just to make sure that you haven't got your pluses and your minuses mixed up. We're doing a straight turn move back along that 2" diameter to Z of -2.5. So we're already at the 2" diameter, so I'll just say incrementally stay there, don't go anywhere. And Z, we're ending up at -2.5. And there's nothing called out here between the endpoint of the turn move that we're doing and the next one. So we'll just push either of the set buttons and we can look at that. Looking pretty good so far. We're here, we're turning out to here, simple turn move. The X endpoint is going to be at this 3" diameter, and the Z endpoint is going to be at -3.25. There is no call out for either a chamfer or a radius at the end of that, so we'll just push set. Now we're going to turn from here to here. X is not changing diametrically, and Z is ending at -4 inches with no call out at the end. We can have a look at that. Looks pretty good. Now we need to turn out to our stock diameter, which is 3.25. So we do a turn, 3.25, and Z is not moving, it's a straight wall, and there's no chamfer or anything at the end of it. Okay, so we've done describing what our finished shape looks like. And now what we have to do is define this stock. In this case, the stock is straight. So what stock is defined by cycle position move. Your X is going straight back. We're already out here at 3.25. We're just going to go straight back to where we started in Z. And we started in Z at absolute 0. So if we look at that now, we see our broken line come across. Now what we do is we end the cycle, and it's going to say that this box is not closed off. Would you like me to close it? And I'll say yes. And it automatically closed the box. So now everything between the solid lines and the broken lines is stock that we know needs to get removed. I'm just going to set up a tool change position here. I'm going to set it up someplace close by. Look at my tool table. Yeah, we're okay with there. And check our tool path. That looks good. We've got a runtime here of 8 minutes and 45 seconds, which is based upon the feeds and speeds and depth of cut and everything that we qualified in our program. Let's go in now, and let's say our stock is Oh, we'll go 6 inches deep. We'll leave 50 thousandths for a bad saw cut on the front. And the diameter of that is 3 1/4. We're now ready to do a solid verification of the G code that you never see, but it's there. And that's going to run the machine. We're at speed 1, which is the highest speed, so you can use your feed rate override if you'd like to take you down as low as single blocking if you wanted to do that. I'll just go at the lowest speed and tell it to verify. This solid model verification is part of our advanced features option, which I highly recommend. So it's roughed it out, and now we can see there's scallops on here. It's going to make a semi-finished pass, which will knock the scallops off, leaving an even amount of stock for the finish cutter that we see running right now. That's it.